Hello again, everyone, and welcome back to Enterprise Linux Security. We're up to episode number 2 today, and we're going to talk about attack vectors. And I have with me, as always, Joao. How are you doing?
All good, Jay. Thank you. It's a pleasure to be here with you again.
Yeah, this is a fun podcast. I really look forward to this one, and a lot of other people seem to be looking forward to it too. So as long as there's a mutual interest, which there seems to be no shortage of that, I think we'll keep this going and have some fun talking about security.
Yeah, exactly.
So today we wanted to talk about attack vectors. Basically, there's all kinds of different things that can go wrong, and we could probably make an entire series called Things That Go Wrong, and we would have no shortage of things to talk about. But in interest of the podcast and, getting a standard flow going and a foundation going, attack vectors need to be talked about because there's different types of things that can happen, very common avenues of attack. And today we have a list of common, I'm going to make that a keyword, common attack vectors, because again, there's so many other things we could talk about.
Yeah.
We have a list, so we're going to go right through it.
Sure. We already covered the CVEs on the previous episode, and basically we went about the vulnerabilities and all that, but we didn't actually get into the details of how those get attacked in the wild. And attacks here, we deal with vulnerabilities all the time. I write a lot about them, and there are always these types of descriptions that mention, okay, this can be exploited through this and this way, and this can be attacked in that specific way. And those are basically the attack vectors. Okay, this is how some malicious actor can exploit that vulnerability and actually reach the goal of either getting into the system or obtaining access that it shouldn't have, something like that. And that attack vector will fall into one of many categories. There are many more than the ones we will cover here today, but these are the most common ones, like you mentioned.
Yeah, I think you'll agree with this, that someone who wants to get into a system, they're going to use the path of least resistance. If it's a password field that they can put a SQL injection or any kind of field, they can pop in some SQL code and have that read. They're just going to do that. If they're going to call somebody on the phone, they're going to call someone on the phone. They're not going to go through hours upon hours upon hours of crunching things just in writing scripts if they don't have to do that. And so basically it's ordered, for the most part, it's arguable, but it's ordered in, least difficulty to most. And first we have phishing. Actually, and we don't mean fishing for fish. We mean, we're fishing with a PH.
Yeah. So phishing is basically a type of attack that where the idea is that you trick someone into giving them their access credentials. You can trick them through some ways like forged emails or to some fake websites that you redirect them through, and then you make it look like the real one, and you wait for your victim to log in or try to log in. You tell them, oh, your credentials are wrong or something like that. But in the background, you're actually trying them on the real system and trying those yourself. So this is very, very common. This is just basically tricking the user into giving you all the information in a fake place. Basically, that's all that phishing is. Yep. And there are very, very many ways where this actually applies. I mentioned the emails, the fake emails. Everybody received emails from banks that you need to update your date or you need to enter your credit card information just to check to see if everything is okay.
Yep. I actually got one yesterday. I'm not even making this up. Like, I got one yesterday. It's like, insert bank name here. You need to verify. And I thought it was interesting that the word POW was in the URL. I'm like, they're not even trying in this one. So these individuals, they're not really trying. But it happens all the time.
Yeah. And in the enterprise, this is especially grave because they will try to, or some attacks will try to make it look like it's the corporate identity management system, and they'll trick you into trying your corporate credentials, and then you're giving out the keys to the castle. If you actually provide those credentials on the fake website, game over by that point. You already let the attacker into the system. So this is not just something that affects the home user, it's also pretty relevant on the enterprise. And basically the only solution here is more training for the employees. The email filters will never catch all of them because they are just too clever with them. Some attackers, instead of writing the text that can actually be detected by some signature or something like that, will just post picture with the text in it, and that will skip the most filters.
Yep.
Yeah, there are many ways around this, and it's very tricky to protect from this type of
It is very
attacks.
tricky. I actually learned some advice in the 90s about how to deal with things in general. That rings true here. In the X-Files, it said trust no one, right?
Yeah.
And that's absolutely how you should handle these kinds of things. And just if something seems suspicious, look into it. I mean, there could be times where, someone calls and says, "Hey, I'm Joe from IT. I need the password because I see there's a virus going through the system," or something, right? Or it could just be someone calling in and, "Yeah, I'm doing a college report. What's the name of your CEO in this person? What's this person's name in this role?" And then they're just writing it down. And then next thing you know, you get some spear phishing emails that are going to very specific people because obviously they can Google this information. They don't need to call for it. But there's also spear phishing, which is more targeted towards an individual that they want to get that individual's credentials.
Yeah, and even in situations where you have those password recovery forms where they ask you the security question number 1 to validate that it's actually you, there is always this type of question like, what's your pet name or something like that.
Oh, no.
So if you ever get that call from someone that claims they're from the vet and that they have your dog there and they're just checking to make sure that all the data is right, don't give them the name of the dog if they don't have it. They're probably just trying to trick you.
Yeah, I have this system. I'm not necessarily saying anybody should use this system because, this is high. Yeah, there's a lot of maintenance with this, but I never give correct answers for security questions ever. I just don't. I have a random number. I use a random generator like a password. I have like anywhere from 15 to 32 characters of gibberish. And I just keep a master list for every website, and every single answer is a randomly generated code because I am not giving them the right information ever.
Nice. I actually learned something from a colleague of mine a few years back, and it blew me off how easy it was to actually do that and how effective it would be. He told me he never entered the correct password when he tried to log into home banking. He always failed the first attempt. So he knew if the site gave him back that everything was okay and that he would be accepted, that wasn't a real website. And it blew my mind. That actually would work. If you type the wrong credentials in your home banking and you get in, there's a problem there.
I actually was listening to another podcast, Security Now, and someone wrote in, and I don't know what bank this was. They sent a screenshot in. What the screenshot said is, someone's trying to sign up for a new account, and it said, "You can't use that password because it's already been used." Now let that sink in for a minute. Oh my gosh. Yeah.
That's a pretty good indicator you should switch banks.
I would definitely say so. So speaking of passwords, brute force, that's something that a lot of outside attackers will try to do. They'll try to brute force your password. They have lists of passwords that are very common, and they're going to try those passwords.
Yeah, and that's basically why almost every site tells you you shouldn't use well-known words or words from a dictionary. You should make up some combination, some random thing. And that's precisely because of it, because passwords will be tested by malicious actors. They have very big lists of passwords that they try. And that's also a very easy attack to perform and very easy to get in if your password is so easy to guess.
Yeah, I think I read somewhere, I wish I saved the article, at least I thought I read, I don't know if you've seen this. I mean, back in the day, I keep saying that, back in the day, but we used to replace I's with ones, right? Threes or E's with threes. I'm pretty sure I read that those have already all been factored in to the tables that they use. So at this point, we can't really get away with that anymore.
Yeah, I keep using the sentence from a book or something like that, where I still switch a couple of words in there, and it's way too long to guess that way. But still, who knows?
Yeah.
Anyway, some years ago, this was actually a pretty tricky thing to do properly because of the speed with which you could generate the passwords and do the tests. But since somebody came up with the idea of something called rainbow tables, which is just to pre-generate the list of passwords and keep those in memory, and the machines actually have enough memory to hold all those lists at once, this attack became much more prevalent and much more easy to deploy. So it's just faster to generate the passwords and faster to test them, and
they're in.
And they're in.
Yeah, I've seen some apps do this, and I like it when they do this. Obviously, this isn't going to fix everything, but it's just neat. You fail the password once, makes you wait 1 second, right? No big deal. Fail it again, it's 2 seconds. Fail it again, it's 4. Then it's 8. Then it's 16. Then next thing you know, you have a 2-minute timeout to try the next password. So that way, it just makes brute forcing that much harder for someone to do. And it's not as inconvenient, because if I just finger my own password, I can wait a second. I can wait 4 seconds, but anything more than that, okay, there's a problem, and that's a big deal. You need to kind of
that's a squared fell off the restriction that they implemented there. Yep. And actually, most enterprise identity management systems will not do that. They will lock the account after a few attempts. They will not take the risk that the password actually gets brute forced. But that has the inconvenience then that support will get many calls a day from people. Oh, my account is locked again. Yeah, somebody's trying your password, and we just locked the account so that he couldn't get to the right password. But that will inconvenience the users, and the users will complain. And if the user is high enough in the chain, he might make the policy change.
I've seen all of that. If you're using LDAP, you got to turn that on. You got to make that lock. Yeah. Absolutely.
Yeah, but I've been in situations where we were dealing with that on a daily basis with dozens of users at the same time, and it's not very easy to keep the users happy in that place.
Right. Well, I mean, they do say that convenience is the enemy of security. So
as we've said before on this podcast,
absolutely.
That's absolutely true.
Yep. So, I mean, there's not much to say about that. Password brute force, it is what it sounds like. It's people trying to brute force and trying passwords over and over again.
It's people trying hundreds of thousands of passwords on every account that they can guess on the system until they find someone that's vulnerable that has a weak password, and they get in.
I don't even care if you're all the way up to date on your patches and everything's perfect. It doesn't matter.
Nope.
Yep. So the next thing on our list is SQL injection, which is I don't know, a little humorous to me, right? You're just filling out a form, signing up for an account, put your first name in there, put your last name in there, your address, and also drop tables. Why not?
Yeah.
Yeah.
Okay, so this comes from the devs not actually putting in the effort of actually validating the input that they get from the users. One of the rules in programming is that you should never, ever, ever trust the input. You should always perform validation, and you should do that at multiple places in the code. It's not just the first function that actually gets the code. You should get that throughout any other function that will deal with that output, with that input. And one of the validations that you should do is if you're actually receiving code where you should be receiving just names or something like that, you should look for keywords that are used in the code. Because like you said, if somebody's last name is drop asterisk, that's going to be a problem if you pass that directly to the database. And there won't be much of a database afterwards. And this is not just for text. We talked about this before we started recording. A few years back, I worked with RFID tags. An RFID tag is basically just a radio antenna and a bit of memory that has an identifier. It's usually a string of characters, 32 characters, 16 characters. It's very small. It has nothing more than that. When it receives a radio wave, it has enough power to send back the identifier that it has. So the first systems that read those types of tags performed no validation. They assumed that nobody would be able to change the memory contents, so they just read the identifier and added it to the database. Malicious actors obviously tried to change the memory contents, and they just simply added SQL commands there. Drop asterisk just to see if it works. Because it was read by the RFID reader and passed directly to the database without any validation, that was another vector for SQL injection. From something as innocuous as, your key fob or something like that.
Yep. All right. So, SQL injection, that's definitely something that we need to keep in mind. And if you're a programmer, check things. Obviously, check what's being put into the
Validate your inputs.
Validate your input. There you go. The next thing is malware. This is personally the first thing that I've experienced that's ever happened to me when I was, green and first starting out in this. When I got my first computer, I think it was within a few months that it happened to me. But I think it's the first thing a lot of people think about but it's not necessarily the first thing that happens. But because Hollywood makes malware popular, right? So calling up someone at the front desk and trying to get their password isn't as exciting as an animation of malware chewing through bytes, but that's kind of not how it is. But there's several different types of malware. So and that's what we're going to talk about right now, because we definitely need to cover that as well.
Yeah, there are several types of malware. Originally, this just basically covered viruses, computer viruses back in the day, not just you that says it. They were usually just small pieces of software that would hide in the background and try to infect other software that you run, other executable files or something like that, and basically just try to replicate itself and perform some task, usually some weird message somewhere, or change your keyboard layout without you knowing, or something like that. Mostly innocuous stuff. And then as operating systems started to evolve and people started to do more valuable things with their systems, it started to become better to actually attack those systems. So we started to see, especially with the internet, we started to see things like worms, which are basically viruses but that have the ability to target systems outside the one they are running and try to replicate in those systems. If you recall a few years back with Windows 95 or XP or something like that, there was this Sasser virus that would replicate through Samba shares. Oh yeah, and that spread pretty quickly because no firewall was blocking that at the time. There was no need to actually block that at the time, so it just spread through the network like wildfire.
Yep.
And
I remember the Nimda worm from. Exactly. I think it was a little bit later on than that, but
it was mostly the same idea.
Yep.
And then we got Trojans, which, like the name implies, it's something that comes up with one purpose and then in the background will do something else that you're not expecting or that you don't actually want it to do.
Oh, you don't want 1,000 extra emojis? I mean, download now, install 1,000 extra emojis.
Or install this new wallpaper, and in the background he's also installing a crypto miner that will steal your CPU power.
Oh my gosh.
But it can be something like an Internet Explorer toolbar that you really, really need, or something like that.
The word toolbar gives me anxiety now, because I remember back in my computer repair days when I would go over someone's place to fix their computer, and I would bring up Internet Explorer, and it would have so many toolbars that the area for actual content was probably like
the screen would be toolbars.
Just like get rid of your toolbars. But it's kind of funny in a way how this graduated over time, because when I was first learning computers, a friend of mine, he made a virus, but he didn't spread it. It was just on his own computer. He was just having some fun with, I forgot what it was. It might have been Visual Basic or something like that. And all it was is just a message on the screen. And when you go to the X to close the window, the window moves out of the way. So you can't really close it because it's just going all over the screen. But obviously you can Alt F4 and it would go away. He thought that was fun, but I guess someone else thought it was fun when I got my first virus, and it just basically made all my data junk data. It didn't really seem to do anything other than delete things, and I'm pretty sure it didn't boot after that. And then fast forward to today, and I kind of figured this would happen eventually as soon as cryptography became like a really big thing, that ransomware is going to hold your machine hostage, your data hostage, and try to make you pay to get back to normal.
Because you're in a really bad position if your data is encrypted. On an enterprise, the data is the most valuable asset you have. Either your customer data or your intellectual property, those are the assets that you really cannot lose. If you happen to have improper backups, or your backup is 1 week ago or something like that, can you afford those days of data being gone? Probably not if you're a big business. No. So you're in the really, really unfortunate position of having your data encrypted and having a message on the screen saying you need to send money to this address. Usually some amount of Bitcoins or something like that.
Oh my gosh, yeah.
Without, and this is the tricky part, without any assurance that if you pay, you actually get your data back. Because you might just be sending money somewhere and never heard from them again. They might not send you the decryptor at all. That's why the authorities always say you shouldn't pay. And you really shouldn't.
No.
I know the situation is really tricky to solve. When you're in that position where you're in that spot, you're the system administrator facing that screen, I know you have to make a judgment call and you have to find the best solution for the problem. but paying, it should really, really be the last solution. Yeah, after you try everything else, even calling the authorities on this. This is serious enough that it should always be reported.
I totally agree with you. And another thing that scares me with ransomware is, enterprise, that's horrible. But what's also horrible and more horrible is that, like when it infects a hospital, you have somebody in the ICU and their data is what's keeping them alive. Like they're like what medication they were given and, how their treatment is going, what the next thing is. I mean, they keep a lot of notes there. And I've seen hospitals get affected by these types of things. So ransomware is horrible. And another thing I've noticed is that even if the attacker does intend on giving you your data back, like they're just a good Samaritan, they're going to do the right thing and you pay them, they're actually going to give your data back, you still might not get it back, because if the FBI takes down the command and control server or whatever, stores those keys, well, you're still done, even regardless of whether or not the attacker decided they wanted to give you data or not. So as you said, it is a horrible situation. It could put companies out of business. Worse, if it affects hospitals, it's a big deal.
It was in the news just a couple of days ago, a hospital in the US that was attacked with some ransomware infection, and they shut down everything. So they had to turn patients away and send them to other hospitals. There were no reports of people actually dying from it, but what if the treatment was delayed or something like that? There are impacts, real impacts to people's lives. In Germany, last year or 2 years ago, somebody actually died because the systems went down due to ransomware, and they were being transported to a different hospital, and they died in transit. Yeah, this is really bad. Currently, this is one of the worst types of attacks, and it's really tricky to get everything back up again. And if it infects a large number of computers in the enterprise, it will take a lot of time to get everything running again. It might take days, weeks, months to get operations back in order again after an attack like this. And you should have backups, but everybody knows that people tend to be a bit lax on that. So you won't have backups 5 minutes ago, just prior to the infection. So you will always lose something if you decide not to pay anyway. But again, paying will probably not get your data back.
Yep. And having an external hard drive on your server attached to your server all the time is not going to help you here. It will get that, and often it'll attack your external storage first before it reveals itself to you. So by the time it shows up on your screen, your backups are gone. So have a solution in place for that.
One of the ways that people got around ransomware when this all started a few years back was through shadow copies on Windows. And the second generation ransomware immediately target shadow copies and erase them if they were present on a volume. So that immediately got taken out of the table, and it's no longer protection. You need backup, and you need offsite, at least offline backup, not attached to any system when one of these attacks happen, or it will also be targeted.
Yep. In my case, I have offsite backups, plus they're versioned as well. So it keeps previous versions up there as well. So you need to be able to go back to a previous version, and don't have it directly attached. If it's cloud storage, don't have it mounted all the time. Absolutely do not do that.
And file servers in the enterprise, that's another target, which is usually mounted on hundreds of computers across the organization.
Shared
drives, that's not a very good day if a shared drive starts being encrypted.
Make them read only. And then we have spyware as well, and that's also something to talk about too. You could have stuff running on your computer that's not working for you, and it's spying and giving away your info.
Again, if you're on the enterprise and your intellectual property is being sent somewhere else without your knowing about it, that's a very big deal. And malware can be something like, malicious Node.js packages like were found a couple of weeks ago that were on the repositories, NPM repositories, they provided some functionality, and in the background they either deployed crypto miners, or they would just steal your information or record your screen or something like that and send it somewhere else. Spyware, while it might not actually mine crypto on your computer, it will still mine your information from it and send it to someone else. And you don't want that either.
No, you don't want that info. No, absolutely not. Another thing on our list is zero-day exploits.
Yeah. So basically, this is when an attacker is looking at the vulnerability list, finds the most recent one, and tries to use that vulnerability to attack a specific system. That's what we call zero-day exploits. It's in the same day as it's announced, basically.
Yep.
Fortunately, or not fortunately, most type of exploits will actually not go after the zero-day exploit. The zero-day exploit tries to exploit that period of time between a vulnerability being announced and actually being patched on the system. That can be anything from hours to days to months or something like that if maintenance is not done properly. But the actual majority of attacks will actually go after older vulnerabilities, because the attacker will be performing reconnaissance on the network and will be looking at the systems that are there and checking for vulnerabilities that are present, and he will accumulate that information over a period of time. He will not immediately act on it. He might sit on that information for weeks and months until he realizes how long it usually takes to apply a specific patch. So zero-day, while it's effective in some cases, it's not the most important attack vector, at least from our experience on TuxCare, from what we've been experiencing and seeing on our customers. It's not the very new. It's not the very newest exploit that gets you. It's the oldest one that you haven't patched yet. It's that thing on that machine that you really don't care much about, that you usually just patch, I don't know, once or twice a year. That's what's actually going to get you.
That is so true. I have seen, these actually affect clients that I've worked with, but it's a completely different area. Like if you're working in like a managed service provider, where you have like a bunch of clients that you're hosting or something like that. At least maybe it could be bad luck on my part, but it seems like a little bit more common over in that vector. But I do agree. It's like the path of least resistance. If it's something that is well known, has been around for a long time, and someone has, exploited that hundreds of times, so they know they can exploit it in their sleep when they see it, they're absolutely going to do that for sure. And for 0-day, the developer has had 0 days to work on the patch, right? That's what it means. It's a 0-day exploit because they've had 0 days to get a patch out there. So
you're actually true when you mentioned that. For some situations, it's actually the problem. The Exchange 0-day exploits a few weeks ago, that was a prime example of that. The exploits came out and they were immediately being looked for on exposed servers all over the internet. Shodan was running scans of that all day long. So yeah, people were looking for those exploits specifically immediately as soon as it had been announced.
You mentioned that, and I'm glad you did, because it seems to me, and I don't have any like statistics to back this up, so I'm just going by what I've seen. It seems like certain software vendors and certain software packages are more the targets for 0 days than others, because I've seen this happen a lot with Atlassian, for example, with their products. As soon as somebody discovers something with any software that Atlassian has made, they're on it. They're going after that. But I think that's probably just because a ton of people use that software and a ton of people don't use it responsibly or host it responsibly. So it's probably still an easy target because of that.
It's probably more because that specific software or software like that has a reputation for being used on the enterprise, and the attackers know that's where their financial gain will come from. So that's where they'll target.
Yep, and it's Java.
This is greed above everything else.
Yeah, totally. Denial of service. This is one of those things where, I remember DOS being the disk operating system, and I have fond memories of playing SimCity on DOS. Those are some great times. But nowadays, we don't use DOS for that. It's denial of service. And this is one of those things where all kinds of people use denial of service attacks. It's not just, outside attackers. I mean, I guess they're always an outside attacker if they're using this. Could be someone, a teenager that's upset about losing a game. So all of a sudden the PlayStation store goes down because they decide to do a denial of service on that. I remember Lizard Squad back in the day was really popular for DOS attacks against things. But enterprises get hit with this. And like we were discussing before the podcast started, it's like, it doesn't mean that you have to have like terabits of bandwidth to make this happen. Although if you do, great. Actually, I'm kind of jealous.
One assumption that is usually made about denial of service attacks is that they only are effective if you have at least the same or more bandwidth than your target, and that you can flood them. But denial of service through flooding is not even the most common attack. Any denial of service relies on you finding some way, you as the attacker, finding some way to have your target stop responding. It can be either slowing him down to a crawl, it can be rebooting it can be taking it offline somehow. But some of the attacks just exploit some kind of feature or flaw in the code, and they don't require that massive bandwidth. Like we mentioned before we started recording, a few years back, about 8 years back, and like I said, time just blurs and can be more, can be less. There was this attack that was popular. It was called Slow Loris. It targeted Apache and other web servers, and it functioned like this. It would send one packet to the web server, and it would keep sending him just 1 byte at a time, just before the timeout for the TCP connection underneath would drop, so that it would keep the connection alive. And the web server would happily spawn a new thread, just receive that data that was coming in, just so that it could serve that client, and the client would just delay and delay and delay. And one attacker could take down any server, basically, just by sending him 1 byte at a time. It took almost no bandwidth to take down major websites with this. And yeah, that was Slow Loris in a nutshell. Just sending him 1 byte at a time, and Apache would happily spawn a new thread. Okay, this is just for you. Send me your request. Tell me what you need. And you would send him GET/, but taking almost 5 minutes to do that, and then just restart for another request. And you could tie up the server. You could tie up the web server 1 byte at a time. You needed absolutely no bandwidth to perform this. So, yeah.
It's just so, it's so easy to do, and that's kind of a big problem. I've seen the other side of this too, where the clients that I was working with over the years, thankfully, I should say, luckily, they didn't get hit by one of these, but they probably will, where they have a server with a load balancer or proxy in front that has a very short timeout. Like it's like, if you better give me that data quick or you're done, and you're out, mm-hmm. Right? But then, someone's uploading a picture, it's 1 megabyte, fine, whatever. And then someone decides, well, they want to upload a 100 megabyte video file. So since it's going through a proxy, of course, it's going to time out. It's receiving data, but I've also seen that it would time out as well because it's, not waiting that long. And then someone goes in and just increases the timeout to like 2 minutes or something like that. I'm like, what are you thinking? If you do that, you might as well just say, hey, DDoS me right now, or DOS or DDoS, just come at me because I have a big timeout here.
Yeah, you mentioned DDoS. DDoS is the big brother to the OS attack. DDoS basically is a distributed denial of service attack. It simply means that instead of having one single attacker entity, you have multiple attackers doing the same attack on the same target at the same time. Basically, that's DDoS. It's the big brother of denial of service.
Yep.
The countermeasures will be the same. You need to find some way to filter traffic, to block the requests that are coming in that shouldn't be coming in that volume or something like that. But instead of having with just one attacker, you have multiple attackers at the same time.
Yeah,
it falls into the same category.
Yep, same category. I've heard some time ago, and I've read this happening, like, your company have this big event, a big software release, and you get this message, it would be a shame if your website goes down while you're having this big release. But if you pay me $10,000, I'll try and make sure that doesn't happen. And then all of a sudden, hey, I'm not paying them. And then their website goes down. And it's one of those reasons why Cloudflare is becoming more and more popular lately.
Yeah, the mob would sell you protection like that.
Yeah. Fun. Actually, not fun, unfortunately. Fun to talk about, unless it happens to us, right? But it won't, because we know this stuff. DNS poisoning. That's another one that's on our list to talk about today.
So basically, DNS is the root of all evil in the industry. Yeah. If you have a problem that you haven't figured out the root cause yet, it's DNS. I wager it's DNS even without knowing what the problem is.
Right.
And the reason for this is that DNS is used by basically anything. Your email will run through DNS to find the appropriate servers to connect to. The web browser that you're using to watch this on, it is using DNS in the background to know to which server it has to connect. DNS is being used on all other protocols and on all other services. And DNS poisoning consists basically in the DNS server accepting fake information as being true. What this means is that you tell him that google.com is not at the address that you think it is, it's at this address that I tell you. And then you redirect whoever is using that DNS server to the one that you want. You won't affect everybody on the internet, but if you're targeting a specific target and you know his DNS server, you poison that DNS server and you make him go somewhere else that you control. And that's DNS poisoning. It can happen through many ways. An improper DNS server will accept updates from clients that it shouldn't accept updates from, or through zone transfers that it shouldn't accept.
Yep.
But as soon as you can get the DNS server to accept fake information, it's game over again for whoever is using it, because you control wherever they go.
Yep.
On any service.
Yeah, so it's the root of all evil. I think it should stand for devil name server, so the domain name server. But I agree, and DNSSEC and a number of other things are coming around. But as everything else, adoption's very slow. So there's some quirks I won't get into, but it is the way forward. Honestly, I would prefer something else other than DNS altogether, but I guess we're going to have it, then we should try to secure it. It's kind of like a cat and mouse game at this point, unfortunately.
And DNSSEC is also vulnerable to some attacks, to some poisoning attacks. So
yeah, it's pretty sad in this industry if we're hopeful for less insecure, right? It's like this new way is less insecure, so we're all about it, but it's still not gonna, really totally fix everything.
We're conditioned to accept that everything has a flaw in this industry, and we've been doing this for so many years now that we just don't find it weird that something doesn't work properly as it's supposed to work. And we accept that it will have flaws and that someone will find them, but it will somehow be exploited. And maybe we shouldn't, but we are conditioned to accept that over the years, and it is what it is at this point.
Yeah, it's like computing is built on Murphy's Law. In general.
Like it is.
So another topic of discussion today in our list is man-in-the-middle attacks.
Yep. So basically, when a client talks to a server to do something, it assumes the server has a certain IP. So when you insert that communication, when you start that communication, you attempt to go to the target, and you reach it, and everything is fine. But if somebody gets into the middle of that communication, say posing as another PC or another system on the network, or faking the IP address of your target or something like that, that's the man in the middle. He will intercept the communication. If he can, he will look at it or may tamper with it. And it can be something as innocuous as sending you a bad content or something like that, or it can change the bank ID that you used, your bank account number, or your crypto address or something like that in a transaction that it picks up. And again, there are some very easy ways to do man in the middle. Like we were just talking, we accept these as facts of life on this industry. We shouldn't, but these types of attacks, they are so easy to do that it's painful to watch.
It really is. I think as a thought experiment for our listeners who are beginners, who are seasoned, who are kind of just looking at this, because I think when you're new, you kind of think of a man-in-the-middle attack as hard because you don't know how to do it. You don't know how easy it is yet. You haven't seen it done. It sounds like, oh wow, how do I get in there? How do I masquerade this IP? They don't know. But if you think about it, you could do a Whois lookup on anyone's domain server, or domain name, I should say, and that makes things really easy because then someone can they have the address. Unless they're using some kind of masquerading service to not show that information on the Whois database. But if someone goes in there and they want to, get into a certain company or something, they could just do a Whois lookup. They have the address of the person who registered the domain. So if they, this has happened, they call up, because this is what kind of links all this together. So they get that information, that's DNS. Then they make a phone call. Now enter phishing, right? They have the address and all this stuff, and they can confirm that, yeah, I'm so-and-so, please confirm your address to prove that. Okay, they give them the address. and they get into that system, and then they get the last 4 digits of the credit card number. Then they go to somewhere else, and now they verify their account over there. And the DNS records are so easy to look up. You could just Google Whois Lookup or something like that, and you'll find a number of different services. And then on the command line, you could just use dig and NSLookup to find out who the, what the name server is for that domain, where it's going, what the IP addresses are. So now you know the IP addresses. This information is extremely easy to find, and essentially all you really need is access to Google to start getting information. So that's why I feel like people in the security industry are always nervous, always anxious, because this stuff is so easy to get to.
Yeah, absolutely. And this could be something so easy as a Raspberry Pi on the target network. Something that's living on a fake roof somewhere, just with an Ethernet cable popping down or something like that. And you can look at the traffic. You can have the device sit there for weeks or months or something like that, just looking at the traffic, just duplicating the traffic, sending it your way for you to analyze, or performing some type of injection in the traffic, masquerading as somebody else in the network, trying to get access. And again, this is not something that's rocket science. No. People will see the movies, will see Tom Cruise popping down a tunnel or something like that, and going through the motions. But in reality, it's not like that. It doesn't need to be like that. It's much easier. It's social engineering, and then just finding the vulnerabilities in your target system. There will be some. People don't patch on time. There will be some. And basically, that's all there is to this.
That's all there is. It's so easy. I kind of also feel like the rogue Raspberry Pi is just going to be a recurring theme through the podcast, because it's like we patched our servers, and we have some amazing firewall rules, and we passed an audit, so we know we're good. We're going to ignore that Raspberry Pi blinky thing, whatever that is, taped underneath the desk over there. That's all the pretty lights on that thing. Yeah, whatever. We have patches and stuff. And the next thing they know, the Raspberry Pi, let's be honest, they have Bluetooth and Wi-Fi. So when he walks by, they can try to, find out what Bluetooth devices are there. It has, the Wi-Fi on there. They could try to have a, rogue access point. And that does happen. I know this isn't security related, but I had to, or I didn't have to, but I decided to install custom firmware on a smart plug. And how do you do it? Well, you use a Raspberry Pi and the Wi-Fi as a fake update server that tricks the device into thinking the Raspberry Pi is the right update server, which then allows you to load the custom firmware. Now, for me, I voided the warranty, but that's my choice, and that's the worst thing that's going to happen. But if something like that is in an enterprise, oh my gosh, just think of all the possibilities there.
You just described the man-in-the-middle attack.
Right,
that's exactly it.
With the Raspberry Pi.
Your Raspberry Pi was faking to be the server. The update server. That's a man in the middle, right there.
It's a pie in the middle.
It's a pie in the middle.
It's a pie in the middle.
I feel we're giving the Raspberry Pi a bad name here. It's an amazing piece of computing. It's a great device.
Yes,
if you're an enthusiast, you should have a couple of them just to run tests and run your, just try these things out on them. They are built exactly for that thing. It's an amazing piece of kit, and you should always use them.
I have probably, I'm not even kidding you, 30 in the house right now, at least. I have a 10-node Raspberry Pi Kubernetes cluster, which I did a video on. Yeah. That was a lot of fun to build. And then, of course, I have like an Open Media Vault. I have some RetroPie devices. I have some test servers are just to play around with. It's almost like a VM stack, but instead of VMs, you have Pis.
Yeah, I actually have one running as a KVM. I followed the PyKVM project. It's a really nice one. And it gives you a KVM device that's better than what comes in most servers. Even top brand servers, they don't have as much functionality as the KVM that you can get with the Raspberry Pi.
Have you looked at the prices of some of these used iKVMs on eBay?
Yeah.
They go for a lot of money. A lot of money. So you can get a Raspberry Pi and you could just totally circumvent that entire thing, and it's way cheaper to do.
$100, $150, and you have a KVM that's better than the top shelf solutions you can find in the market.
People pay $500 plus for these things. I've seen some go for $4,000 new.
Yeah. And even the ones that are embedded in the server motherboards, this one is better than that.
Yep.
This is free publicity for the project. We are expecting our copies of the new hats.
Yay! That sounds like such a fun project to work on. So yeah. Yeah, Raspberry Pis are cool, but if you see one that you didn't buy and didn't go through the purchasing, requisition system and isn't in your hardware database, you probably should look into it.
Yeah, absolutely.
Yeah. So I think that was everything, unless you have any other thoughts.
There are many other attack vectors, cross-site scripting, then lots of other more specialized attacks. But yeah, I guess for today, this is enough attack, and people should already be scared after all this. So yeah, this should be enough for one episode. We might revisit this in the future and come up with a few others to talk about. It's pretty easy to find them.
Yeah, and also in addition to that, I mean, any one of these topics that we've glossed over, like we said at the beginning, it's a summary. We could go into detail on any one of these, and we most likely will.
Absolutely.
This is just getting started, but we're going to go deeper and deeper, because I think it's great when you can listen to a podcast from the first episode, if depending on your experience level, and work your way through the episodes, and then your knowledge builds up as you go through them. I think is a really great thing.
And if people actually want us to go into detail over a specific one of those, just let us know.
Yep. Absolutely. So I guess that's our episode. That was episode number 2 of this awesome podcast. I love this podcast. I'm biased. What can I say?
It was a pleasure, Jay. Thank you, everybody, for joining.
Thanks for watching or listening.
Bye.
Bye.